Bless you. Number 1, 2, and 3 are pretty easy. Number 4 and 5, 6, they are not in standard form, so you got to do the process of completing the square. Completing the square. That video there is not going to play on that phone. Alright, number 4, 5, and 6. So number 4, we're going to complete the square. Anybody have trouble completing square number 4? Are we good? I need to explain that one, or are we good? Yes. I got my x's together, and then got my y's together, moved the 4 over. Took half of this, which is negative 2. I squared that. That's positive 4. If I add 4 here, I must add 4 here. Took half of that is 3. 3 squared is 9. I add 9 to the other side. That gives me 9. Good morning. My center is opposite of what you see, 2 and negative 3, and my radius is 3. Number 5, I only had x squared, so I don't have to worry about that. Yes, ma'am. Can you make it more than 0 here, or at the end of the class? Thank you. Okay, x squared is right here. I'm going to have my y squared minus 12y. Since I only got x squared, I know that my coordinate for x is going to be what? 0. Does everybody understand that? Took half of 12 is 6. 6 squared is 36. Add that. I get 61. My center is 0, 6. Take the square root of that. I can't break that down, so that is my radius. Are there any questions on that? And then number 6. First of all, I notice on number 6, what's not in front of x squared? 1. You need 1. So I look there. What number can I take out of all of them? 4. I divide the whole thing by 4, and I get x squared plus y squared minus 2x plus 6y. Do the completing the square process. I get 1, negative 3, and square root of 10. Are there any questions on those homework problems? Yes, Tyler?
So, do you always just divide it by that first number, even if you can't take it out, just turn it into a fraction?
On the circles, it's normally going to be that first number.
Okay.
But ellipses are not going to be like that today. I don't want you to think about it. You're just reducing it. All right. Check 7, 8, 9. Oh, you'd have to do 8, but 7 and 9 right there. Oh, sorry. Number 11 says the center is at negative 1, 4, so that's easy to write this part. But it says it's tangent to x equals 3. I drew a little diagram to see. X equals 3 is a vertical line. My center's there. It says it's touching this. So I got to count. Okay, if it's tangent, it means it's touching. So if I'm right here, if I count over 1, 2, 3, 4, that's 4 away, so 4 squared is 16. Does that make sense? Are we sure? Mason, you good? Number 13 and 15 says it's the center's at this and passes through this point. Yes, you could draw a picture and look at it, or I just wanted you to practice distance formula, so I did the distance from the center to the edge is 5, so 5 squared is 25. Square root of 256 is 16. 16 squared is 256. Do y'all agree with 13 and 15? Just close your notebook. You don't have to put it off the desk. start when you get it. Take your time on this one. I found this one at the bottom of my drawer. Ask her if she can. Ask the teacher if she can give that to her, please. Thank you. We have 1 minute remaining. You can use your calculator to subtract that last one. That's quicker for you. You better not type in those sine, cosine, tangent right now. Some of y'all doubt me. When I see your faces. I'm going to give you about 25 seconds to finish up. If you're done, somebody collect them in your group. I'm going to come around and get them in. After you're done, please turn to your page 3 in your notes and ellipses. We're about to hit ellipses hard today. Did you buckle up that seatbelt? We talked about yesterday what conic sections are known as. They occur when you have a plane intersect a cone. And here's where the shape of ellipse would come. If it was kind of the plane intersecting this called a right cylinder cone at like an angle, you would see an ellipse. Okay? Now I want you to look at those two pictures. These are not bad. Like, these two are the easiest way to form. And the reason I can go over these things is because they are on the ACT. So this is not a hard one, but there's a lot of information you got to take in. What do you notice about the two pictures at the top? Like over here, you got one on the top, one on the bottom.
Oh, it's part of the same thing as in the 3D coordinates.
Well, no that direction, but
One's vertical.
very good. You know, Mason just said there's the orientations. One's horizontal orientation, one's vertical. Okay, so yes, ellipses can be either horizontal or vertical. Do I have all quizzes? All right. So, if it's horizontal, here's the equation. Ellipses are always set equal to 1. Ellipses always involve a plus between the two fractions. Okay? So that's going to be always a plus and a 1. You know how we read the center for a circle? It's opposite of what you see in the parentheses? That's the same for an ellipse too. Okay? That's the same thing. So if I saw x minus 2 plus y minus 3, my center of my ellipse would be 2, 3. Is everybody good with that? Now, here's where we need to talk about a squared and b squared. A squared is always your larger number of the two. Okay, and I'm going to talk to you about what that means in a minute. For instance, this is horizontal. A is always your larger number. It's going to be under the one that tells you the orientation. So you see how A is under the X? So at least you know that that's going to be horizontal. In a minute, down here's the same equation, but since this is vertical, where do you think the A squared is under? The Y, okay? So I don't memorize equations. I don't memorize those formulas. Just know that the larger numbers under the parentheses that tells you the orientation of the ellipse, okay? So let's talk about what A and B values are. Let's say we have the center of this ellipse. It's at HK. I got that from here. HK. A squared. Just the regular value A, not A squared. How would I find A? By taking the square root of A squared, wouldn't I? A is the distance from your center out to your edge of your ellipse. So that's what the value of A is. It's the distance from the center to the edge. Okay? So this would be A0. This would be negative A0. What do you think B? This is known as the major axis. Major axis. So A is the distance from the center to the edge on the major. What do you think B is? The distance from the center to the what? Top, the minor axis, okay? Does that make sense? So from here to here, this would be 0, negative B, 0, B.
Yeah, why is negative B?
It should be positive. Sorry, that should be negative. Now, the ellipse has a special point called the focus. Plural is the foci. Say foci. 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 Okay, so that is a special point on the ellipse. And the foci always occur on the major axis. You need to know that. The foci is always on the major axis. So I'm going to let this be negative C over here and C over here somewhere. Like this is, I'm just explaining the process to you. You're not going to have to draw this picture or anything. But what do the foci do? Well, the foci tells you this. If I was to pick any point on the ellipse, let's say I picked the point here. And I calculate the distance. Let's say this is D1 and D2. A point from this focus and from this point to this focus. What is the significance of that? The significance is if I added the two distances, it equals 2 times the A value. That's what a focus is. You're not going to have to recall that information to me, but that is what a focus is. Oh, no, the foci equation, we're going to get to that in just a second. We're on page 3, Parker. All right, so you got A squared, B squared. Your foci equation is C squared equals A squared minus B squared. And it's the same down here as well. C squared equals A squared minus B squared. Okay. So looking at this picture, my A, if I found the square root of A squared, that would be A. That would be from my distance from my center up here. You see that? My B would be from my minor axis from here to here. Where would my foci be located, on the vertical or the horizontal? Vertical. It's always on the major axis, okay? So this will make sense in just a second when we start finding them. Oh, I'm sorry. Alright. So let's look at number 1. We want to find the center and the vertices. That means 4 of them. And then sketch the graph, okay? So number 1. Is it in standard form? Is there a plus, and is it equal to 1? Yes. Okay? So what's my center for this? 0, 0. Okay? Now I'm going to ask you this. By looking at the equation, you determine the orientation. Is this going to be a horizontal or vertical? Why is it going to be vertical? Very good. The larger numbers under the Y. Very good. So let's identify our A and B. What's A squared equal to? Okay, the larger number is your A squared, so that's 4. What is A equal to? 2. What is B squared equal to? 1. B is equal to 1. Now you have enough information to graph this ellipse and tell me the vertice, okay? Now you can sketch your graph on your paper. I'm going to do it on this right here so you can literally see what I'm doing. Alright, so you have to graph it before you can tell me the vertices. You can't just say, oh, I got enough, I can... Okay. So my center, 0, 0. You told me it's going to be vertical, which is correct. So that means, am I going up 2 or up 1? Up 2, and then what? Down 2. And my B value tells me I'm going to go over right 1 and left 1. And there's my ellipse. So then I write down my vertices. 0, 2, 0, negative 2, 1, 0, negative 1, 0. So my answers are the center, the vertices, and my graph. How y'all feeling the first one? Let's look at number 2. Number 2 is not in standard form. Why is that not in standard form? It's not set equal to 1. That's the problem. That's the major problem. Alright, so how do you think you're going to get that set equal to 1? How can I make 144 and 1? divided by 144. So if it's not set equal to 1, you take this last number and divide everything by it. 16 divided by 144, that's going to be x squared over 9, I believe. So that's the rule. If it's not set equal to 1, you take what's in it and divide everything by it, and then reduce the fractions. Now, once I have that, is it in standard form? Yes. What is my center? 0, 0. Is this going to be a vertical or horizontal?
Did you clear the number?
No, what I did was I had to get this set equal to 1. So 144, how do I make 144? Divide it by 144. So if I do it on this side, I do it on that side. So that's legal in math. So that's equal to 1. 9 over 144 reduces to 1/16. I reduced the fraction. 9 goes in that one time. 9 goes in that 16 times. I just reduced the fractions. Does that make sense, Jack?
Oh, I know that. I'm just saying it was like, I thought x would be over 16. Like x squared.
Why would it be over 16? Because you got 16 over 144. 16 goes in at one time. 144 divided by 16 is 9. Okay. All right. Now, you said it's going to be vertical. That's right. So what's my a squared equal to? 16. So what is a equal to? 4. B squared is equal to 9. B is equal to 3. Now, yes, you can put plus or minus 3, plus or minus 4. That reminds you to go right, left, up, and down, but that's okay. I'm not going to be that particular on it. I'm just worried about your vertices. All right, let's graph it. It says center at 0, 0. It is vertical, so I'm going to go up 4. 1, 2, 3, 4. 1, 2, 3, 4. Go out 3 from each side. And that is my ellipse. So my vertices would be 3, 0, negative 3, 0, 0, 4, 0, negative 4. So that's what I'm looking for, that and the center. This is what you test on first, circles and this. So you said you don't really use the foci to graph? No, but you will use the foci when we start writing equations. Are there any questions on 1 and 2 so far? So the first 2 learning targets were just identifying the centers, the vertices, and graphing. So that's our first 2. Okay, look at number 3. Is that in standard form? Is it set equal to 1? Is there a plus in there? Yes. All right, so what's my center for this one? 1, 2, very good. What is, okay, is this going to be a horizontal or vertical orientation? Because the larger numbers are on the x. Okay, so what's a squared equal to? 4, a equals. B squared equals. B is equal to. Okay. would be my ellipse there. My vertices would be at 1, 1, 1, 3, 3, 2, and negative 1, 2. I put some graph paper here, so if you need some for homework tonight, or to just have it, you don't want to draw them, you can, okay? If you'd rather do that than drawing them on that piece of paper. Are we good on the first three? Okay, let's turn it over. I'm going to do 4 and 5, and then we're going to do some equations. 4. What's wrong with 4? It's not equal to 1. Now, how did we say we're going to do that? Divide everything by what? 100. When I do that, can I reduce the 25 over 100? Yes, what would that become? X plus 2 squared over 4 plus y minus 1 squared over 25 equals 1. Because you're reducing 400s to 1. And once I do that, I'm going, hey, I can work with that. All right, what's my center there? Negative 2, 1. Is this going to be a horizontal or vertical orientation? Vertical, and we know that because the 25 is going to the y. So therefore my a squared value is 25. My a would be what? 5. That means I'm going to move 5 units out from my center vertically. My b squared is 4, so my b value is 2. So this information here, I can graph it now. So center's at negative 2, 1. My a is 5 as vertical. So for this particular one, this would be my graph. For this information here. Does anybody have a question how I got the center, the A, and the B right here? And then this is the graph for number 4. It's not too bad, is it? We'll do one more like this, and then we'll move on. Let's look at number 5. Number 5. Now, when we did the circle lesson, here's my stressor. Usually it was that number we divided everything by that 4 and got it. You can't do that here. First of all, it's set equal to 0. Can I divide that by anything and get 1 there? No, that's how these are. This is different from this. You could divide this and get 1. Here I can't do that, can I? So here, these are the ones you got to complete the square on, like we did yesterday. Okay, completing square. So, I'm going to do this on a separate sheet of paper. So we're going to complete the square on this one. And I knew I had to do this process because it's set equal to 0, and I can't get a 1 there. But I got to make a 1 get there somehow. All right, I'm going to group my x's together. Notice I put a plus there because it's got to be a plus for it being Equation of ellipse. Now this one right here, if you look at that first parentheses, what do you notice is in front of x squared? 4. When we did completing square, what needed to be there? A 1. What can I take out of 4 and 16? 4. So I'm going to take out a 4 there. What can I take out of this y over here? A 9. I have got to do that there in order to complete the square. Now, everybody good so far on that? We're going to complete the square. Half of negative 4 is what? Negative 2. Negative 2 squared is? I'm going to add 4 there. Now, my question to you is that, I know I need to add something there. Do I just need to add 4? What do you think? That's correct. Madison said we need to add 16. Yes. If I put plus 4 here, I got to take into account there's a 4 out here, don't I? So that's why you add 16 in this case and not 4. Okay? So I took half of negative 4, squared it, that's 4. Add that 4, but if I distributed that out, that would be a plus 16 over here, wouldn't it? That's why you add 16 over there. What's half of 2? 1 squared is? Am I going to add 1 or 9 on this side? 9. Does that make sense? Alright, now that's going to be x minus 2 squared plus 9y plus 1 squared equals, what's that? Do that add for me. 11, 16. Is it 36? 36, thank you. Alright, now we're at a point I can get it set equal to 1, can't I? I'm going to divide everything by what? 36. Reduce that to x minus 2 squared over 9 plus y plus 1 squared over 4 equals 1, and that's my equation. We're not going to graph this one. The main thing, because we're running out of time, I just want to just see you see the process how to get to that, okay? Because I want to do 2 equations of ellipse at the bottom, okay? Alright, let's look at 7 and 9, and then we'll call it a day. We'll finish this tomorrow. How do y'all feel on, besides this one, I know some of us might have to look at this one a little bit, but the other ones, do you feel okay about those? Okay, we're going to do another one like that tomorrow. Alright, number 7. It says, write an equation of ellipsis, our last learning target, for the given information. Alright. Do you see how all these got zeros everywhere? So what do you think the center is going to be? 0, 0, okay? If you can't see that, graph it. I do advise students who have trouble with this to graph it because it comes out. But you can graph it like this. Quick to sketch. You don't have to be perfect. So you can draw you a quick sketch, and you can clearly see the centers at what? 0, 0. I just tell students, if you see stuff like that, like number 7, number 9, number 8, you see those zeros, that's 0, 0. But here, remember, this one don't have a 0 in it, does it? So number 10, your center's not at 0, 0. Do you see the difference in those? Okay, so center's at 0, 0. So I can go on and put x squared plus y squared equals 1. Now, when I graph that, guys, is this vertical or horizontal? Vertical. So my bigger numbers got to be under what? Y. What is my distance from my center to one of those edges? 5. Will I put 5 or 25 under Y? 25. What will I put under X? 16, and that's my equation. Let's skip down to number 10. Okay, I'm going to graph this. This is the vertex at 0, -4, and 6, -4. The focus is at 1, -4, 5, -4. So let's graph this. And yes, I'm going to let you have graph paper during the test where you can just make your quick drawing wherever you need to. I just graphed the dots they gave me, my edges and my focus. Now, this is the key part about focus. Focus is always on your what? Major or minor axis. So, is this going to be horizontal or vertical? Horizontal. So, the bigger number is going to be under X. Let's find the center, though. If I keep moving in, where's my center going to be? You see why my center is right there? So what coordinate is that? 1, 2, 3, -3, -3, -4. So I can go and put x minus 3 squared plus y plus 4 squared equals 1. I know that part. I got to figure out what my A and B are. I know that it's a horizontal. My bigger number's going to be here. Well, I can find that by looking at the picture. If this is my center and this is my edge, how far away am I? 1, 2, 3. So what's 3 squared? 9. Now my question is, how do I find what b squared is equal to? Well, there was a formula a while ago. What was it? C squared what? Equals a squared minus. Now from this diagram, you can tell with C deals with the focus, doesn't it? How far is the foci from the center? 2. So what's 2 squared? I can put 4 there. Because you just graphed them. The foci are these points right here. It says in your problem, foci is here. You found the center. So 2. So 4 equals 9 minus b squared. And just solve the equation. You get -5 equals -b squared. Oh, doesn't those negatives cancel out? 5 equals b squared. Remember, this is where students mess up. This is b squared, isn't it? I got b squared. So what will I just put there? Will I put 5 or 25? 5, because it's already equal to b squared. Do you see that? And that would be your answer for that ellipse. Okay, we're going to stop there for the day. We're going to continue practicing these equations tomorrow. I just wanted you to have some background, okay? So your homework tonight is 8 through 26 even. The first part reviews circles. And the second part of it starts talking about ellipses, okay? We're going to hit this hard again tomorrow, and then you'll be ready to do your test on Thursday. Parker, is that coming back to you?